శైలజ మేడం స్టార్ట్ చేయండి. Unmute please. No. Madam start చేయండి.
Hello?
Yes ma'am, start చేయండి.
State webinar series. It is a moment. Good afternoon, sir. Sir, Additional Director sir is there with us. Good afternoon, everyone. I take this show State Model Schools webinar series journey started on 29th June 2020 in model schools. The first webinar session by Sridevi Polu Madam, Principal TSMS Pudu, followed by various subjects are coming forward and are very enthusiastic in taking the webinar sessions. This shows the energy of Telangana State Model Schools. In the terms of viewership, sir, I would like to tell the statistics of our Model Schools Telangana YouTube channel. In terms of the viewership, we have more than 7,400 subscribers in less than a month. The watch, that is the number of minutes they are seeing our channel, is more than 1 million minutes, around 11,40,000 minutes. So subscribers are 50% who are viewing the channel, and non-subscribers are 43% who are viewing our channel. And the impressions or the number of persons who are glancing, who are at a glance looking into our videos of the webinar sessions is more than 2 million. I thank Director Sri Sachayan Reddy Garu and Joint Director Rajiv sir for their encouragement and support in this endeavor. And I also thank the whole webinar team who are rendering their service and guiding the resource persons for quality transmission of the sessions. Thank you one and all. Our motto is to take learning to the students in this pandemic. Stay learned, stay. Thank you, sir. I would like to request our Additional Director, sir, to speak a few words on this occasion.
Sir, disconnect అయ్యారు.
Let us look into the wonderful journey. Madam, please play the video. Madam, please play the video of our journey.
సార్ జాయిన్ అవుతున్నారు.
ఓకే ఓకే సార్. సార్ జాయిన్ అయ్యారు సార్.
అడ్రస్ చేయమనండి.
గుడ్ మార్నింగ్ టు ఎవ్రీబడి.
గుడ్ మార్నింగ్ సార్.
వినపడుతుందా?
వినపడుతుంది సార్.
ఓకే ఓకే. ఇంతకుముందు కూడా మాట్లాడినా సరిగ్గా రీచ్ కాలేదు అది. గుడ్ మార్నింగ్ టు ఎవ్రీబడి. కంగ్రాచులేషన్స్ టు ఆల్ ద మోడల్ స్కూల్ స్టాఫ్, ప్రిన్సిపల్స్, టీచర్స్ అందరూ కూడా మనం ఒక మంచి ప్రయత్నం మొదలు పెట్టాము. సక్సెస్ఫుల్ గా 50 సెషన్స్ కంప్లీట్ చేయడం చాలా మంచి అది. అందరికి కూడా మరొకసారి కృతజ్ఞతలు. ఈ విధంగా మనం కొంచెం దీన్ని కొంచెం ముందు తీసుకెళ్తే బాగుంటది. ప్రత్యేకించి మనం టీచర్స్ కు ముందుగా మనం స్టార్ట్ చేసాము. టీచర్ల ఫస్ట్ దీనిపైన టీచర్లకు కొంత అవగాహన ఉంటే బాగుంటుంది నా ఉద్దేశం. అందుకని మనం టీచర్లందరికీ కూడా ఈ సబ్జెక్ట్ టీచర్కి ఒక 2 days లేదా 3 days ఈ ఆన్లైన్ క్లాసుల నిర్వహణ, దాని తర్వాత ఫర్దర్ గా ఏం చేయాలి, అదేవిధంగా 10th ఇంటర్మీడియట్ తో పాటుగా 10th క్లాస్ ఏమన్నా స్టార్ట్ చేసే అవకాశం ఉంటుందా, అదేవిధంగా ఇంటర్మీడియట్ వాళ్ళకు ఈ లెసన్స్ తో పాటుగా ఈ ఎంసెట్, ఐఐటి, జేఈ ఇలాంటి నీట్ ఇలాంటి ఏమన్నా ఇతర ఆర్ట్స్ కోర్సులు కూడా క్లాట్, సిఏ ఇలాంటి అవి కూడా ఏమన్నా ప్లాన్ చేస్తే బాగుంటుంది అనేది ఒకసారి ఎవరైతే దీన్ని ఆర్గనైజ్ చేస్తుందో కోర్ టీం అందరూ ఒకసారి మరోసారి ఈ వెబ్ ద్వారానే జూమ్ ద్వారానే అందరూ కూడా డిస్కస్ చేసుకొని ఒకసారి ఫర్దర్ గా ఒకటి టీచర్లకు ట్రైనింగ్ 10th క్లాస్ కు స్టార్ట్ చేయడం, అదేవిధంగా కాంపిటేటివ్ ఎగ్జామినేషన్స్ కు అవసరమయ్యే విధంగా కొంత కోచింగ్, కొంత అలాంటి సెషన్స్ కూడా కండక్ట్ చేస్తే బాగుంటుందని నా ఉద్దేశం. ఇదైతే చాలా చక్కగా, చాలా అప్రిషియేషన్ ఉంది. వేరే వాళ్ళు కూడా అంటున్నారు, ప్రైవేటు కార్పొరేట్ విద్యా సంస్థలు కండక్ట్ చేసే ఆన్లైన్ క్లాసుల కంటే కూడా ఇవి చాలా క్వాలిటీ ఉంది, క్లారిటీ ఉంది, చెప్పడం కూడా బాగా చెప్తున్నారు అని అందరూ కూడా చెప్తున్నారు. ఇది చాలా మనకు మంచి సంతోషకర విషయం. ఇది దీన్ని మరింత స్ట్రెంథెన్ చేస్తూ దీన్ని ముందుకు తీసుకుపోవాలని అందరినీ కూడా కోరుతున్నారు. థ్యాంక్ యూ.
శైలజ మేడం.
వెరీ మచ్ సార్. ఇప్పుడు చిన్న స్టాటిస్టిక్స్ సార్. ఇన్ టర్మ్స్ ఆఫ్ వ్యూవర్షిప్ వి హావ్ మోర్ దెన్ 7,000.
Oh, very good.
The YouTube channel is 1 million minutes, sir. And the number of persons viewed videos at a glance are more than 2 million. So
Okay, very good.
YouTube channel Telangana, sir. Thank you, sir. Thank you for support and encouragement, which is holding the webinar team for quality transmission.
Okay.
Thank you.
వెరీ గుడ్, వెరీ గుడ్. ఇప్పుడు నేను చెప్పిన లైన్ మేడం శైలజ గారు, మంజరి గారు, నేను చెప్పిన కొంచెం ఆలోచించండి. టీచర్లకు ట్రైనింగ్ ఒకటి, ఈ కాంపిటేటివ్ ఎగ్జామినేషన్స్ కు కొన్ని క్లాసులు, ఫర్దర్ గా 10th క్లాస్ చేయగలుగుతాం అనేది కొంచెం ఆలోచించండి.
Definitely, sir. Thanks for the encouragement, sir, given, and we'll try to accommodate the training for teachers as well as students. We'll definitely have given the direction, sir. Definitely, we'll follow the direction. We'll start also, sir. Thank you so much for providing your gracious.
Very good, very good. Okay, good.
For the entire team of webinar for this wonderful journey, I request Ide madam play of our journey.
Okay, good. Right. లైన్ ఉన్నారా?
దీపా మేడం.
సార్ ఉన్నా సార్.
మేడం
మీ టీం ఎవరైతే ఉన్నారో మరి మీరు మాసారి కోఆర్డినేట్ చేసుకోండి.
సార్
ఓకే, ప్లాన్ జాగ్రత్తగా కూడా ప్లాన్ చేయండి, కంటిన్యూ చేయండి.
ఓకే సార్. మీరు చెప్పిన అన్ని ఇంప్లిమెంట్ చేస్తున్నాము. టీచర్స్ ట్రైనింగ్ అండ్ అదర్ క్లాసెస్ వెబినార్స్ ఆల్సో వి విల్ థింక్.
Okay, very good, very good.
Deepa madam, please start.
Yes, madam. Good afternoon, respected additional director, sir, and my fellow principals and teachers, and my dear students.
Okay.
I am
Good
very
morning,
happy to
good morning.
share that today is our 50th session of mathematics. Students, you are very lucky to have such an experienced staff who are taking every care in delivering their best and make you understand the concepts in a better way. Mr. Sanjeev sir has been doing such a thing since few days. He has explained you a lot of topics in the circles, and today he'll be continuing with the circles chapter with few more topics like chord of contact and etc. Over to Sanjeev sir.
Thank you, madam. So, shall I start? So, welcome to the 15th session of the webinar series of Telangana Model School. So, today's topic we are going to start is called as the chord of contact. So, you have been discussing about the circles for past few days. Now we've been discussed about what exactly is a tangent and what is the equation of tangent. The equation of tangent we represented as S1 is equal to 0. Then we have taken up the condition of tangency. What is the condition that the circle, the line can be called as a tangent to the given circle, and we discussed about what is a normal, and we have also discussed about the equation of normal, and we also taken the concept of point of contact of the line and the circle. So these concepts are going to be used in today's class. So today's topic is actually chord of contact. Before knowing about the chord of contact, we need to understand what exactly the tangent from a point mean, right? So how many tangents are there from a point, and all these aspects we are going to discuss. So tangent from a point. So what is the meaning of it? So if you take a circle, S is equal to 0, and if P x1 y1 is an external point, then you can say there exists two tangents from the point P. So one tangent, you see that there are two tangents. One is PT1 and second is PT2, right? So you are going to prove that whenever you take a circle here, and if you take the point P as an external point, then you will be having two tangents for the circle. Right, so geometrically we can represent like this, but we have to show that theoretically that the point P, if it is an external point, then you can draw two tangents from the external point to the circle which is given. So for that we take a circle whose center is C and radius is R. So you have taken a circle here, and the center of circle you are calling it as minus G minus F, because you have taken circle equation as S is equal to 0. And the radius of the circle is given as root over G square plus F square minus C. We have already learned about this. Now we take up the line here. There are two lines here. So once you have got a line, definitely you will have a slope. So you take, let M be the slope of the line of the tangent passing through the point P x1 y1. So the slope of the tangent, either this one or this one, you can call it as M. Okay. Now, what is the equation of tangent whose slope is M? See, you have discussed about the equation of tangent in your earlier classes. So generally you take the equation of tangent if slope is given as y is equal to mx plus c. But you have got a condition of tangency. The condition of tangency was given as c square is equal to r square into 1 plus m square. So we can write c is equal to plus or minus r into root over 1 plus m square. But the center is not 0, 0 here. Center is minus g minus f. So the equation of tangent with slope m is given as y minus or minus f. So y plus f is equal to m into x minus or minus g, which you can write as x plus g, plus or minus r into root over 1 plus m square. See, you got a plus or minus. It indicates that you'll have two values of m's. Okay, so the equation of tangent with slope m for the circle S is equal to 0, we have discussed it as y plus f is equal to m into x plus g plus or minus r into root over 1 plus m square. So you need to solve this equation. So for that, what you can do is, you see that this line or the tangent line is passing through some point. What is the point you have taken? X1, Y1. So it means that this line should satisfy this point. So since the tangent line passes through the point x1, y1, so we can replace x with x1 and y with y1. So we get y1 plus f is equal to m into x1 plus g plus or minus r into root over 1 plus m square. So you need to solve this equation. So to solve this equation, the first step what you do is bring this m into x1 plus g onto the left hand side. So what you get is y1 plus f minus m into x1 plus g is equal to plus or minus r into root over 1 plus m square. Right hand side, you see that there is a square root. Left hand side, there is no square root. So you can take a squaring on both sides. So you can write y1 plus f minus m into x1 plus g whole square is equal to r square into 1 plus m square. So because you are taking a plus or minus and you are going for squaring on both sides, so plus or minus r whole square is going to be plus r square. So you got an equation like this. Now left hand side, what you are observing, it is an equation in the form a minus b whole square. So if you call the first term as a and second term entire m into x1 plus g as b here, a minus b whole square, you know it as a square minus 2ab plus b square. So a is nothing but y1 plus f, b is nothing but m into x1 plus g whole square. Now you expand it. So you can write y1 plus f whole square minus 2 into y1 plus f into m into x1 plus g plus m square into x1 plus g whole square is equal to, or you can get the r square other side. So minus r square m square is equal to 0. Now what you have done is you have taken a minus b whole square here. Then you brought this r square into 1 minus r square left hand side, r square into m square with a plus sign coming to left hand side is minus r square into m square is equal to 0. So you have got the first term y1 plus f whole square minus 2ab. A is y1 plus f, b is m into x1 plus g, and b square, which is m square into x1 plus g whole square, then minus r square m square. So what is that you find here in this equation? You got m square terms, you got m term, and you don't have any m term in this, the first term here and the before last term. These two terms don't have m. So you try to expand this or rearrange this as a quadratic equation in m square. So quadratic equation in m. So you can write it as x1 plus g whole square minus r square, both having m square, so of m square. Then m term minus 2 times y1 plus f x1 plus g, and the terms which are not having m as last, so y1 plus f whole square minus r square. So you have taken the term here m square into x1 plus g whole square and minus r square m square. You have taken m square common and you wrote the first term x1 plus g whole square minus r square. Then you wrote the term minus 2 into y1 plus f m into x1 plus g as minus 2 times x1 plus g first, then y1 plus f, and finally m. Then the terms which are not having m, y1 plus f whole square minus r square. So when you regroup this, it is coefficient of m square. The first term is coefficient of m square. Then this entire minus 2 into x1 plus g into y1 plus f is coefficient of m, and this is what is a constant term. So constant term is y1 plus f whole square minus r square. So students, kind of make a note of these three values. This is what is in the form a m square minus b m plus c. So you want to have two roots. So you have to show that it is having two roots. So when you got this possible that it is having two roots, equation 1 is a quadratic equation m. So it is going to have two roots. The roots of equation 1, if at all it is real and distinct, then If its discriminant is positive only, you can say that this is possible. So the discriminant should be positive. So what is discriminant? What is discriminant? If you take equation as ax square plus bx plus c, then discriminant is given as b square minus 4ac. So recollect the values of a, b, c which you have taken here. So you can write it as delta is equal to discriminant is equal to, now this what is the coefficient of m. So minus 2 x1 plus g into y1 plus f whole square. So b square. So the b term is given here, minus 2 into x1 plus g into y1 plus f, minus 4. A value is here x1 plus g whole square minus r square, and c value was y1 plus f whole square minus r square. So this is what is the value of a, b, c. You applied a value here, b value here, and c value. You are going to find the value of delta. So in finding the value of delta here, you got minus 2 square. So minus 2 square is minus 2 to minus 2 is 4. Here also you got 4. So 4 and 4 at both places, you can take 4 common. So when you take 4 common, write the remaining terms, x1 plus g whole square into y1 plus f whole square. 4 is taken common, minus x1 plus g whole square into y1 plus f whole square. So you are multiplying these two terms, x1 plus g into y1 plus f. Then you got r square term multiplied here, r square term multiplied here. So you can write minus into minus is plus r square times x1 plus g whole square plus y1 plus f whole square. Then you got minus r square. You can write as minus r square whole square. So one little step of expanding it, you got like this. Now what you're observing in this expansion, you got x1 plus g whole square into y1 plus f whole square, and you got x1 plus g whole square into y1 plus f whole square. So they both are in the opposite signs. So we can cancel it off. So you can cancel it off, and you got you are left out with the remaining terms here. So in these terms, you see that again there is a r square common. Already you have taken 4 common. Now you are seeing that r square is also common. So take it common. So 4 into r square, x1 plus g whole square plus y1 plus f whole square minus r square. So r square whole square, one of the r square is taken here, isn't it so? So one more r square is left out. Now expand this, a plus b whole square, here also a plus b whole square. So you can write as 4r square into x1 square plus 2gx1 plus g square plus y1 square plus 2f(y1) plus f square minus g. R square value we already taken as radius is given as square root of g square plus f square minus c. So r square is going to be g square plus f square minus c with a negative sign. So you got a plus g square and minus g square. You can cancel off these two. You got a plus f square and minus f square. You can cancel it off. Then you got a minus and minus, minus into minus is plus. So the remaining terms, if you write it here, it is 4r square into x1 square plus y1 square plus 2gx1 plus 2f(y1) plus c, right? So recollect what is this expression, x1 square plus y1 square plus 2gx1 plus 2f(y1) plus c. We have given it as separate notation. We call this as S11. So you can write as 4r square into S11. Now, where is the point? The point is outside the circle. So once the point is an exterior point of the circle, we have got a condition that S11 is greater than 0. This was a condition, S11 is greater than 0, right? So this value is greater than 0. S11 is greater than 0. 4 is also always greater than 0 because r square is there. Square of a number is always positive. So all these 3 numbers are positive. So we can say the value 4r square S11 is always greater than 0. So what you got is delta is greater than 0. So delta is positive. So once delta is positive, so it means that the roots of equation 1 are real and distinct. So once it is roots are real and distinct, it means that 2 should have 2 values of m. So we have 2 real and distinct values of m. we can call it as a one as m1 and second as m2. So if you put the value of m1 in the equation which you have taken earlier of equation of tangent, you get one tangent. If you put the value of m as m2, you get the second tangent. So because you have got two values of m, you are going to get two tangents. So hence we have got two tangents from an external point px1, y1. So whenever you have got an external point to the circle, always remember that you can have two tangents from that external point to the given circle. So we can draw maximum of two tangents from an external point to a given circle. Now, what is going to happen if these two values, the m1 value and m2 value, are same? If m1 is equal to m2, then the roots will be real and equal. So the meaning of m1 is equal to m2 means that the m1 and m2 are coinciding. So once the value of m1 and m2 are coinciding, then you'll have only one slope, right? So the delta is equal to 0. You get roots are real and coincident, or roots coincide. That means that m1 is equal to m2. Therefore, you can say the tangents coincide. So what do you mean by tangents coincide, right? You can have only one tangent. So it means that the point which you have taken, it was earlier external point. Whenever you have got an external point, we have to get two tangents. But once you got only one tangent, that means that the point has to move from the external point and should be on the circle. So this is possible only when the point lies on the circle. So when you got the point on the circle, you'll have only one tangent at that particular point. So if you take a circle, you have got infinite number of tangents, but at a point which you discuss, you can have only one tangent. Whereas if the point is outside the circle, you are going to have two tangents. Okay. Now, what is going to happen if this delta value is negative? So negative means the roots are imaginary, not real, right? So if you get delta is less than 0, then the roots are imaginary. So once the roots are imaginary, then you don't have any real lines. So no tangent is passing through the point. So once you got the situation that roots are imaginary or no tangent is possible, how it is possible? Only if the point is lying inside the circle. So if the point lies in interior of circle, then you will not have any tangent. So remember, see, three simple things. One is, if the point is lying outside the circle, you got two tangents from the point. The point is lying on the circle, you get only one tangent from that point. The point is inside the circle, interior of circle, you cannot draw any tangent. So depending on the position of the tangent point, whether we can say that it is having two tangents or one tangent or no tangent, we can decide. If the point is exterior point, you get two tangents. If the point is on the circle, you get one tangent. If the point is inside the circle, you don't get any tangent. So simple. Now let us take external point P here, and you have taken two tangents. So one I call it as PT1 and second you call it as PT2. And center of circle you have taken it as C. Now here, when you take the distance between center and the tangent, you can call it as radius. So CT1 or CT2, you can call it as radius. So these two values, you can call it as radius. So radius, if you represent as R, and this length PT1 or PT2, T1P or T2P, they are called as lengths of the tangents. So what is the formula of length of the tangent? Remember, length of the tangent is given as root over S11. Now, the question is here, if you got two tangents like this, and if theta is the angle between these two tangents, if you take a T1P-T2 angle, T1P-T2 angle is going to be theta. Now, if you just join C and P, then what is a bisector? You have learned in your 10th class. So if this is a bisector here, if the entire angle is theta, this is half the theta. So it is theta by 2 and this is also theta by 2. So if theta is the angle between the tangents through a point P x1 y1 to the circle, then Theta by 2 will be the angle made by the line joining the center at the point and the tangent. The relation between theta, radius, and S11 is given by the formula tan theta by 2 is equal to R divided by root S11. So you can prove this simple result. It is a very, very simple result of geometry here. So how you can prove it? You see that this is a right angle triangle. Where is the right angle? The angle made between the radius and tangent is always 90 degrees. So this angle will be always 90 degrees. So is the angle here. So we are only taking this triangle P T1C. In this triangle, right angle is here. If this is a right angle, which will be the hypotenuse? The CP is going to be the hypotenuse. Now you are observing from here, this is angle theta by 2. So this is going to be the opposite and this is going to be the adjacent. So this is opposite and this is adjacent. So the tan of the angle, so tan theta by 2 is equal to opposite by adjacent. So opposite is CT1 and adjacent is T1P. So CT1 we are already called as radius. So radius you generally represent as R. And length of the tangent is T1P. So PT1 or T1P both mean the same. So this length is root over S11. So the tan theta by 2 is equal to R divided by root over S11. Okay. So it is a relation between the angle between the tangents, radius of vector, and length of the tangent. Now just concentrate on this part here. You got right angle triangle already here. So if at all you want to find the area of this part, again this part, so you can say it is half into base into height. So what is the base here? If you just observe from here, this is going to be the base, this is going to be the height, because this is a right angle here. This is going to be the base, this is going to be the height. So it is half into CT1 into PT1. So CT1 into PT1. So half into CT1 is R and PT1 is root over S11. So you can say that the area of this triangle is going to be half into R into root over S11. You want to find the area of this region. What do you call this entire thing as? These two are equal. These two are equal. We can call it as a kite. Remember, in your 9th class, you learned about it. Okay. So area of this kite is going to be twice the area of this triangle. So it is going to be R into root over S11. So let us take a small problem based on the formula which you have discussed. Find the angle between the pair of tangents drawn from point 1, 3 to the circle x square plus y square minus 2x plus 4y minus 11 is equal to 0. So you got this point 1, 3 as an external point and circle equation is given like this. So what is the formula we are going to use? Just now we discussed. The formula was tan theta by 2 is equal to R divided by root over S11. So you need to find out what is radius, what is root over S11 from the information given. So first of all, what is given? Equation of circle x square plus y square minus 2x plus 4y minus 11 is equal to 0. So this is what is 2g, this is what is 2f, this is what is c. So 2g is equal to minus 2, 2f is equal to 4 and c value is minus 11. So from that you can get the value of g as minus 1, f as 2 and c as minus 11. So what is the formula of radius? Radius is given as root over d square plus f square minus c. So you need to substitute the value of g, f, c here. So g value is 1, f value is minus, g value is minus 1, f value is 2 and c value is minus 11. Substitute the values, you get 1 square minus 1 square, 2 square and minus of minus plus. So it is 1 plus 4 plus 11. So 1 plus 4 plus 11 is root 16. Root 16 value is 4. So you got the value of radius as 4. So you got R value. What else you require? You need to find out root S11. So first of all, you are going to find out S11. So what is the given point? The given point is 1, 3. So S11 is nothing but simply replace x with x1 and y with y1. So you get x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. So you substitute the value of x1 as 1 and y1 as 3. The value of 2g is already known as -2. The value of 2f is 4 and the value of c is -11. When you substitute here, what you get is 1 square plus 3 square, x1 square plus y1 square minus 2 into 1 into 2 into 1. 2g is 2 here, x1 is 1 and 2f is 4, y1 is 3 and c value is -11. So expand this 1 plus 9 minus 2 plus 12 minus 11. So here 1 plus 9 minus 2 plus 12 minus 11. So when you just simplify this, 1 plus 9 is 10, 10 minus 2 is 8, 8 plus 12 is 20, 20 minus 11 is 9. So you got the value of S11 is 9. So we have got a formula of the relation theta, radius and S11. So the formula is tan theta by 2 is equal to R by root over S11. Now, you know what value of R here? R is 4. Root over S11 is 9. So root over 9 is 3. So 4 by 3. So tan theta by 2 is 4 by 3. So you can say tan square theta. Why you require tan square? Little later. Okay. So tan square theta is equal to 4 square is 16 divided by 9. Now you want to find the angle between the pair of tangents. So you're going to find the angle theta, not theta by 2. So to get that, we have to use the formula which you are used in the first year. So what is the relation connecting tan square theta by 2? You got any relation? The angle. So you got 3 relations. One is sine theta is equal to, second is cos theta is equal to, third is tan theta is equal to. So whichever you like, you can take it up. So you can write cos theta is equal to, generally we take cos here. So cos theta is equal to 1 minus tan square theta by 1 plus tan square theta by 2. So 1 minus tan square theta by 2 by 1 plus tan square theta by 2. So now why you have taken tan square, you understand here. So straight away you can put the value of tan square theta by 2 as 16 by 9. So you get cos theta is equal to 1 minus 16 by 9 by 1 plus 16 by 9. So 1 minus 16 by 9 plus 1 by 16 by 9, you can write LCM as 9 minus 16 by 9 plus 16. So what is the value you get? Minus 7 divided by 25. So cos theta is equal to minus 7 by 25. So theta is equal to cos inverse of minus 7 by 25. So you got a relation first here. Cos inverse of minus theta is equal to pi minus cos inverse of theta if the value of 7 by 25 is less than 1. So you got pi minus cos inverse of 7 by 25. So how you have solved the problem here? You can take the radius first, then you have found out S11, then use the formula. And to get the value of theta from theta by 2, you have used the relation cos theta is equal to 1 minus tan square theta by 2 by 1 plus tan square theta by 2. And you got the answer. So let us take another problem of the similar kind here. Find the condition that the tangents drawn from 0, 0 to the circle S is equal to 0 be perpendicular to each other. So you are going to find the condition that tangents drawn from origin to the circle are perpendicular to each other. So for that, you start with the radius. S is equal to 0, radius is given as root over g square plus f square minus c. Now you require S11. See again, because it is said perpendicular to each other, the angle is given as 90 degrees. Remember that. So R is given as root over g square plus f square minus c. S11 is given as x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. But from where you are finding from 0, 0. So what is the meaning of it? You can put the value of x1 as 0 and the value of y1 as 0. So from 0, 0, S11 is going to be x1 is 0, y1 is 0. So you are going to have only c here. Remaining all terms will vanish. So what is the value of S11 here? The value of S11 is c. So you got R value, you got S11 value, and you know the angle as perpendicular. So tan theta by 2 is equal to R by root over S11 is the formula here. The value of theta is perpendicular means 90 degrees. So 90 is nothing but pi by 2. So theta is pi by 2. Why you are taking pi by 2? Tangents are perpendicular to each other. That is what is a keyword given to us. So you're going to take value of theta as pi by 2. So once you take theta is equal to pi by 2, then tan theta by 2, because you require tan theta by 2, so it is half of this pi by 2. So half of pi by 2 is pi by 4. But what is tan pi by 4? Tan 45 degrees or tan pi by 4 is 1. So tan theta by 2 is 1. Now you got tan theta by 2 value. You know what is the value of R. You know what is the value of S11. S11 value is C. R value is root over G square plus F square minus C. And tan theta by 2 value is 1. Substitute there. You get 1 is equal to root over G square plus F square minus C by root over C. Now you see that you got a root C in denominator. You can take cross multiplication. Root C is equal to root over G square plus F square minus C. So you have got a square root on both sides. So what is it you can do? You can remove the square root, squaring on both sides. So C is equal to G square plus F square minus C. So bring that C onto other side. So you get C plus C. 2C is equal to G square plus F square. So what is the condition that the tangents drawn from origin to the circle are perpendicular to each other? The condition is 2 times the constant value is nothing but the coefficient of G, coefficient of X square, half the coefficient of X square and half the coefficient of Y square. So G square plus F square is equal to 2C is the condition for this problem. So you can take this as a result in solving some bits. In MSET, all this, they can give problems like this. So here, having understood the problems here, so let us take another question, which is usually remembered as a formula and taken as a 4-mark question in the IIB examination. So show that the area of the triangle formed by 2 tangents through the point Px1, y1 to the circle S is equal to 0 and the chord of point of contact with respect to S is equal to 0. So here you got the triangle here. So this problem, okay, fine. Try to understand what exactly is chord of contact. Its chord of contact is a line between the 2 tangents. So it is a chord between the 2 tangents. Okay. So here, what is that you're going to find out? You're going to find the area of this triangle. So to find the area of the triangle here, what is given is, we know what is PA and what is PB. What is PA? Root over S11. And PB is also root over S11. And if you take the angle between the 2 tangents as theta here, so let PA comma PB be 2 tangents through P to the circle S is equal to 0 and theta is a angle. So we know tan theta by 2 is equal to R divided by root S11, the formula which you got. Then you're going to find the area of the triangle. What triangle? Triangle TBA. So to find area of triangle here, once you know the 2 adjacent sides and angle enclosed, then you got a formula in first year, properties of triangle. It is half AB sine of theta. So it is PA and PB. These PA and PB are 2 adjacent sides and theta is the angle. So sine of the angle into half the value of length of the first side and length of the second adjacent side, the formula is half into PA into PB or half into A into B sine theta. So what is PA? PA is nothing but the length of the tangent. So what is the length of the tangent formula? Root over S11. So it is half into root over S11. PB is also root S11. This is also length of tangent. Now sine theta I write in terms of tan. So 2 tan theta by 2 by 1 plus tan square theta by 2. So the formula sine theta formula is 2 tan theta by 2 by 1 plus tan square theta by 2, which you learned in your first year trigonometry here. So you can put the value of tan theta by 2 as r by root over S11. Root S11 square you can write. You can remove the square and write simply S11. So it is half. 2 and 2 also can cancel. So this is S11. Now tan theta by 2 is r by root over S11 by 1 plus r square by root S11 square is S11. So you take LCM here. The LCM is S11 in denominator. So that S11 goes to numerator. S11 square divided by into r by root S11 you can write as S11 whole to power of 1 by 2 by S11 plus r square. So you can see that there is a S11 whole square and S11 whole to power of 1 by 2. So when you got these two terms, you can simply write as S11 whole to power of 2 minus 1 by 2. So 2 minus 1 by 2 is 3 by 2. So you get the area as r is there, S11 whole to power of 3 by 2 by S11 plus r square. So the angle made between the tangents of the circle and the line joining the tangents, which you can call it as chord of contact, is given as r into S11 whole to power of 3 by 2 by S11 plus r square. So I have taken this problem because I just wanted to use this formula first. So before actually discussing about chord of contact, what you have discussed earlier, we have discussed about the tangent made from the point, external point. So the tangent made from external point, how many tangents you have drawn? You can draw 2 tangents. Okay, so if you take if the tangents drawn from the point through the point Px1 y1 to the circle S is equal to 0. This is what is circle S is equal to 0, right? So you have got 2 tangents here. These 2 tangents touch the circle at 2 points. What are the 2 points? One is point A and second is point B. So you are going to draw tangent to the circle from an external point Px1 y1. The tangent is touching the circle at 2 points. One is A and second is B. Now when you join this AB, so this line is what is called as secant. Then the secant AB is called chord of contact of P with respect to circle S is equal to 0. Again I repeat, if a tangent is drawn through the point Px1 y1 to the circle S is equal to 0, touch the circle at 2 points, one is A and second is B, then the secant AB is what is called as chord of contact. This line is what is called as chord of contact. Okay, so what is chord of contact in simple words? It is a line between the 2 tangents. Okay, fine. So this chord of contact should have an equation. So you're going to find out what exactly is the equation of the chord of contact. So you take a point, external point Px1 y1 to the circle S is equal to 0. The equation of chord of contact of P with respect to the circle S is equal to 0 is given as S1 is equal to 0. Now what was S1 is equal to 0 we have taken earlier? You have taken it as equation of tangent. Now you observe that same S1 is equal to 0 is also the chord of contact equation. But chord is different, tangent is different here. Okay, so here chord of contact equation is given as S1 is equal to 0. Now the tangents drawn from P x1 y1 to the circle S is equal to 0 touch the circle at 2 points. One you are calling it as A, second is B. So the coordinates of A you are calling it as x2 y2 and the coordinates of B you called as x3 y3. Now, first of all, you are going to find the equation of tangent at this point and also find the equation of tangent at the second point. What is the equation of tangent formula? We have got the formulas. So simply replace x1 with x2, y1, y2. So equation of the tangent at point x2, y2 is x2 plus y2 plus g times x plus x2 plus f times y plus y2 plus c is equal to 0. Now, we have got it as something like s1 is equal to 0. Here, because you are taking the point as x1, y1, you are calling it as s1 is equal to 0. If you take the point as x2, y2, you can also call it as s2 is equal to 0. Okay, so here the point is x2, y2. So replace the x1, y1 with x2, y2. Here you get x2 plus y2 plus g times x plus x2 plus f times y plus y2 plus c is equal to 0. Right? Now, at the third point, what is the third point? B x3, y3. So x3, y3 equation of tangent. Here, replace x1 comma y1 with x3 y3. So the equation will be similar to this equation. Only thing is, instead of x2 and y2, you'll have x3 and y3. So see that it is x3 plus y3 plus g times x plus x3 plus f times y plus y3 plus c is equal to 0. So you got equation PA. Also you got equation PB. So these two tangents which you have taken, they pass through which point? This tangent PA or PB pass through this point PA. So that means that the point P is common point to both the equations here. So the P x1 y1 should satisfy the PA equation, should also satisfy the PB equation. So if at all you take this, these tangents pass to the point x1, y1. So it means that it has to satisfy. So you can replace x with x1 and y with y1. So you get the equation as x1, x2 plus y1, y2 plus g times x1 plus x2 plus f times y1 plus y2 plus c is equal to 0. So what was this equation? Do you remember earlier? It was called as S12 is equal to 0, right? So same S12 you got it here. Now what you observe here is x1, x2, y1, y2, gx1, gx2. So what you do is, in these two terms, you take x2 common. x1, x2, gx2. Take x2 common. So once you take x2 common, what you get is x1 plus g. Likewise, y2 common, y1 plus f. Then gx2 plus fy2, gx1 plus fy1 plus c. This is not taken. Gx1 is not taken, fy1 is not taken. So gx1 plus fy1 plus c is equal to 0. Likewise, you take the second equation earlier there. Again, do the same thing here. So x1, x3 plus y1, y3 plus g times x1 plus x3 plus f times y1 plus y3 plus c is equal to 0. Now again, you collect the x3, y3 commons in the first two terms. So you get it as x3 into x1 plus g plus y3 into y1 plus f plus gx1 plus fy1 plus c is equal to 0. So what is it you are observing in both the equation 1 and equation 2? Are you observing anything common? In both the equations, you got x1 plus g, y1 plus f, gx1 plus fy1 plus c is equal to 0. So in both the equations, you got this x1 plus g, y1 plus f, and gx1 plus fy1 plus c. So the strangers are x2, y2, and their x3, y3. So if you take the point, generalize this point in place of x2, y2, or in place of x3, y3, you put a point x comma y. So what is going to happen? So you can say that a x2, y2 and b x3, y3 satisfy the equation. Which equation satisfies? So you can replace x2 with x and y2 with y, or x3 with x and y3 with y. So you can write as x times x1 plus g plus y times y1 plus f plus gx1 plus fy1 plus c is equal to 0. So if you just expand this, it is xx1 then yy1 plus g times x plus x1 plus f times y plus y1 plus c is equal to 0. So both these equations are one the same. This equation and this equation are one the same here. Only thing is this rearrangement, and you got like this. Remember this equation, what sort of equation it is? This was called as S1 is equal to 0. Right? So we observe that equation 3 is a straight line. This straight line which you got is what is called as chord of contact. So the equation of chord of contact AB is xx1 plus yy1 plus g times x plus x1 plus f times y plus y1 plus c is equal to 0, or simply s1 is equal to 0. So if at all you got an external point here, any external point, the equation of chord of contact and the equation of tangent, generally they represent in the same way. Only thing is the position of the point is important here. If you take from here, you got this as x1, y1. If you take from this as a point here, it's what going to be the x1, y1. So if you at all you take the point, earlier you have taken the point as external point. Now, if the point is on the circle, instead of the point here, the P here, this is a point P here. If the P happens to be somewhere here, then you can say the tangent equation itself is a equation of chord of contact. So if the point lies on the circle, both the tangent or the chord of contact mean one and the same. So you can say the chord of contact is a tangent. Now, if you take the point in the inside the circle, so definitely you not have any chord of contact. Why don't have a chord of contact? Because you cannot draw any tangents from the interior point. So because there are no tangents from interior point, there is no chord of contact. So you understand here, if the point lies outside, you will have a chord of contact. If the point is lying on the circle, the equation of tangent and equation of chord of contact is one and the same. The point is lying inside, you not have any chord of contact. So let us take one simple problem on this. Find the equation of chord of contact of the point 0, 5 with respect to circle x square plus y square minus 5x plus 4y minus 2 is equal to 0. So here equation of circle given like this: x square plus y square minus 5x plus 4y minus 2 is equal to 0. What is the value of 2g, 2f and c? G, f, c. So 2g is equal to minus 5, 2f is equal to 4, c is equal to minus 2. So from that you get the value of g as minus 5 by 2, f as 4 by 2, 2, and c is minus 2. So g, f, c values you got. Now what do you want to find out? You're going to find the equation of chord of contact. So if nothing is there, the point is not satisfying this equation. See here, put x is equal to 0 and y is equal to 5. When you put x is equal to 0 and y is equal to 5, this value is greater than 0. So the point should be lying outside. If nothing is mentioned, generally the point is lying outside the circle. So the point x1, y1 is 0, 5. So equation of chord of contact formula is s1 is equal to 0. So s1 is equal to 0, we know it as xx1 plus yy1 plus g times x plus x1 plus f times y plus y1 plus c is equal to 0. Now you got x1, y1 value as 0, 5, g value, f value, c value, you know. Substitute and Get me the answer of the equation of chord of contact. To substitute the value of x1, y1, g, f, c in this equation and get me the equation of chord of contact. The point is lying outside the circle. So x1 is 0, y1 is 5, g value is minus 5 by 2. F value is 2, c value is minus 2. So you can see that 0x is 0, 5 into y is 5y, minus 5 by 2 into x. So 5y minus 5 by 2x, 2 into y is 2y, plus 10 minus 2 is equal to 0. So 5y plus 2y is 7y, minus 5 by 2x, 10 minus 2 is 8 is equal to 0. So you can take LCM there. So you can get as 14y minus 5x plus 16 is equal to 0. So rearrange it. So 5x minus 14y minus 16 is equal to 0. So the equation of chord of contact here is 5x minus 14y minus 16 is equal to 0. So what you have done today is we have taken the tangents from external point and we have got the equation of the chord of contact and equation of chord of contact. So what exactly you learned from this today's session? How many tangents are possible from an external point? If at all you take an external point, you will have how many tangents? 2 tangents. If the point is on the circle, how many tangents are possible? Only 1 tangent. And if the point is inside the circle, then how many tangents are possible? No tangent. Then what is the formula for angle between the tangents? This is a 2 marks question for IPE and also important formula for mains or even MSET. Tan theta by 2 is equal to R divided by root over S11. Then chord of contact. So what is chord of contact? If at all you take a tangent, 2 tangents, the line joining the tangents to circle is what is called as chord of contact. And the equation of chord of contact is S1 is equal to 0. So let us take some practice problems on this. Find the chord of contact of 1, 1 with respect to circle. So when you got a circle equation as x square plus y square is equal to 9, the chord of contact is similar to the tangent equation xx1 plus yy1 minus r square, because center is 0, 0, g is going to be 0, f is going to be 0. So you get x1 value is 1, y1 value is 1, minus 9 is equal to 0. So orally you can tell the answer, but just try to practice it. Find the angle between the tangents drawn from the point 1, 3 to the circle. X square plus y square minus 6x plus 4y minus 11 is equal to 0. So you are going to find out what is radius of circle, what is length of the tangent, then use the formula. Tan theta by 2 is equal to R by root over S11. Then what is the condition that tangents drawn from external point GF to circle S is equal to 0 are perpendicular to each other? So this is a similar problem which you got instead of earlier 0, 0, you got G, F. So try to solve this problem here. It is similar to the problem what you have done today. Only thing is instead of 0, 0, you have taken the point as G, F. Okay, so you just try to practice these 3 problems. We have discussed only one concept, that is chord of contact. So the theorems which are discussed in today's class may not be directly asked in the examination, but we need to know how actually the things have come. So that reason we discussed all the theorems. So in 2B examination point of view, IP point of view, no one is going to ask how this theorem has come, how this theorem has been proved. But you need to understand the concept so that it is going to be easier. Whenever a problem is given, you are going to draw a rough diagram. So to understand the rough drawing the rough diagram, if you are able to prove the theorems, then it becomes easy for you. So with this, I try to conclude this, and if at all any doubt is there, I would like to clarify it. Yes, ma'am.
Thank you, Sanjeev sir. Today's class was very clear. Only thing is the students must be aware of the formulas from trigonometry.
Yeah, that is important actually. They need to
Yeah.
actually have a good idea of trigonometry. No,
Without that,
every time like I'm recollecting the formulas which have been used. So at least these formulas, whatever next time they can actually recollect these formulas, whatever you got in your first year intermediate.
yes, sir. That's what, because last year topics means they will leave at the end. They may not recollect it, but whenever you are telling, compulsorily you are making a point that the old formula must again be repeated here. Rest everything was good, sir. Thank you, sir.
Any doubt is there actually?
No, sir. Nobody has asked any doubt.
Like I'd like to just add one more thing here. So students who wish to actually know the solutions, I'll put the solutions after 2 days of the class, right? So today Monday here, so I'll put the solutions in the chat box on Wednesday. So the previous solutions have been put in the chat box of the previous videos. If they would like to know the solutions, they can go back and get the answers, final answers. So thank you, ma'am.
Okay, sir. Fine. Thank you.